Next, we have DRAM and NVRAM. Dynamic RAM is a read or write memory in which the information is stored in the form of electrical charges on a gate-to-substrate capacitance of a MOS transistors. DRAMs are faster than the SRAMs and consume less power in a quiescent state. Non-volatile RAM or NVRAM are called flash memories. These memory devices are electrically erasable in the system, but it requires more time to erase. Yeah, than a static RAM. So these are also called EEPROMs and can perform about 100,000 of operations. Okay. So by the way, when we say
Quiescent.
quiescent, as you have heard, no, in you have heard, quiescent is it means that inactive or passively. No. So this means to say that DRAMs are faster and consumes less power in when it is in a passive state. Interfacing EEPROM and SRAM. So the primary function of memory interfacing is that microprocessors should be able to read from and write into a set of semiconductor memory IC chips. EEPROM is interfaced for read operations. SRAM is interfaced for write operations. In order to perform the read-write operation, number one is memory access time should be less than the read or write time of the processor. Two is chip select signals should be generated for selecting a particular memory IC. Third, suitable control signals should be generated for read or write operation. Fourth, a specific address should be allotted for each memory location. So this is the typical EEPROM and SRAM. Now, a semiconductor memory IC will have N address pins and M data pins. Such a memory has 2 to the power of N locations, and each location can store M bit data. So, the size of the data stored in each memory location is called the memory word size. In 8086-based systems, normally memories with word size of 1 byte are used. If the memory IC has M data pins and N address pins, then it will have a capacity of 2 raised to N times M bits. When M equals 8, the memory capacity is 2 raised to N bytes. So as you can see in this table, this is the memory capacity depending on the number of pins. And it's also being widely used now. For example, if you have known no some flash drives, wala tay 6 gig, 6 gigabyte na memory capacity of flash drives because the memory capacity is being calculated as 2 raised to n, and each location can store again a number of data, mbit data. So we have 1 gigabyte, for example, 2 raised to n. But in this case, no, in a microprocessor, specifically in 8086, the number of address pins, which is 10, is equal to 1024 in kilo, that's 1K. In hexa, that's 400. So meaning to say that the range of address in hexa from 000 to 3FF can be stored. Okay, so up until the 20 number of address pins, which can store up to 1 megabyte, no, or 1024 kilobytes. And the range of address in hexa is 00000 5 ka-F. So again, ang memory capacity up until now is wala dyan na siya 6, 5. So ano na siya? 1, 2, 4, 8, 16, 32, 64, and so on and so forth. But if you can try, no, na lang, if you have seen, no, pag i-right-click ninyo ang storage sa inyong sa mga storage devices, ang memory capacity niya sometimes dili gyud na siya 2 gigabytes. Sometimes it only takes up to like 1.9, no? Or ang 4 gig nimo is sobra usahay, no? So the generation of chip select signals, no, we have actually what we call decoders. No, I know that you have already this in your logic circuits. Ang decoders kasi, they are used in generating chip select signals. So ang 2 to 4 decoder gives for chip select signals. The 3 to 8 decoder gives 8 chip select signals. The 4 to 16 decoder gives 16 chip select signals. Now, if the decoder outputs are connected to the chip select pins of ICs in the microprocessor system, at any one time, only one chip will be selected. The inputs to the decoders are the unused address lines or high-order address lines. So in the generation of chip select signals, while interfacing memories, the low address lines are connected to the memory ICs. The remaining unused address lines or the high order address line are connected to input of decoder. So the inputs of decoder are connected to the CS or CE pins of memory ICs. In a microprocessor-based system, all the memory ICs and peripheral ICs are connected to a common system bus. Therefore, the data, address, and control lines are connected to all the slaves. But all the slaves remain in high impedance state, so they cannot communicate with master through bus. But they are, physically connected but electrically isolated. So some of the decoders used in microprocessor is ang decoder 74LS138. And you have already designed a decoder as much as I know. And you can create your own decoder by having a truth table, right? So there's no need to discuss this one. And a 2 to 4 decoder, no? We have the 74LS139. This one. Now, how does the memory organization in an 8086 based system look like? So this is the memory organization in an 8086 based system. Ang 8086 microprocessor, again, is a 16-bit processor with a 20-bit address bus and a 16-bit data bus. It can access 1 megabyte of memory. Latches and buffers, we have this one. So the address and data buses are multiplexed in the 8086 microprocessor. Latches and buffers are used to separate address lines A0 to A19 from the data lines D0 to D15. This setup helps in addressing memory locations correctly. So ang structure of a memory bank is divided into the add bank memory and even bank memory. Each bank consists of EEPROM or erasable programmable read-only memory for storage of firmware or program code. Ang RAM dinhi, no? Ang bank, again, each banks we have SRAM, EEPROM and RAM. But here, it's a static RAM, no? But nakalagay dyan is RAM. So, ang RAM dyan is for data storage and program execution. So, each EEPROM and RAM chip has 256 KB of memory. In the addressing scheme, the even bank, for example, will be accessed if A0 equals 0. So, even bank siya. For example, 0002 hex, 0000 hex. Then sa add bank naman is accessed when A0 equals 1. So, kani siya ang ma-access. A19 helps in selecting between multiple memory chips, and the CS, which is the chip select signals, are used to activate the correct memory chip. Data bus from D0 to D15. We have that here, kani siya, kana data bus. I can need the D0 to D15. Yeah, I think that's it. D0. Yan. Okay, data bus, data bus. So since the 8086 has a 16-bit data bus, it can read or write 16-bit words at a time. So even addresses, A0 equals 0. Sa even addresses, even bank memory will be activated. If that's the case, the data will be transferred via D0 to D7. However, if the A0 equals 1, add bank memory will be activated. So pag 1 daw ni siya si A0, kani ang ma-activate, no? Ang data karon will be transferred sa D8 to D15. Okay, so that is the data bus in memory organization. We have control signals, read and write, no? Read and write control signals manage the memory operations. Kani siya. So ang output kaning OE, which means output enable, allows reading from EEPROM. Ang write naman, or WE, is write enable, is used for writing to RAM. We also have the BHE, kani siya, which is the bus high enable. This selects the upper byte from D8 to D15 sa data bus for word operations. Okay, so that's pretty much it for the memory organization in an 8086-based system. Napademi. So in addition to what I have mentioned earlier, memory organization in an 8086-based system, we have the lower 8 lines of the data bus, which is from D0 to D7. Again, it's connected to even bank memory. Ang upper line naman is connected to the odd bank memory ICs. So a microprocessor system requires both kaning EEPROM and RAM. But in this case, we use the static RAM because static RAM is often used in small-scale 8086 systems because it is faster and it does not require refreshing. For this system's memory bank, 256 KB of EEPROM and SRAM is available. If the 256 kilobyte memory space is implemented in a single IC, then it is required to have two numbers of 256 KB, SRAM and EEPROM. The odd and even memory banks are connected to the respective data bus lines. Yes, so I made mention earlier that if it's 0 or low, then the even bank ICs will be selected. Pag odd bank naman, when the BHE or the bus higher enable is low. Okay, so dili kayo siya ma-imagine, no? Dili because how do I say this? Because everything was wordy. But I hope you can find some more information about the memory interfacing of 8086 microprocessor. In summary of our lecture today, a memory unit is an integral part of any microcomputer system, and its primary purpose is to store programs and data which can be categorized as processor, memory, main memory, and secondary memory. The primary function of memory interfacing is that the microprocessor should be able to read from and write into a set of semiconductor memory chips. A microprocessor-based system requires both EEPROM and RAM. Hence, the available memory space ay dapat i-divide between EEPROM and RAM. This choice depends on the system designer as well as on the application for which the system is designed. So it really depends. And that ends our lecture for today. Do you guys have any questions?